physics and unit conversions. So for problem number 34, we are asked to find how many milliliters are in 2 fluid ounces. And then for part B, we are asked to find the number of ounces in 100 grams. And in the textbook, we are given a picture, and the picture is going to help us find how many milliliters are in 2 fluid ounces. If we look at our textbook, we'll see that there's no conversion for fluid ounces to milliliters directly. However, in the textbook, we actually have a picture of a bottle of vegetable oil that has already gone through and done the conversion for us. So in this particular case, we have to kind of think outside of the box, and we notice that by looking at the picture that 16 fluid ounces is equal to 473 milliliters. That was given to us in the picture in the textbook. So using that conversion, we know a couple of things. We know that there is a direct relationship between 16 fluid ounces and 473 milliliters, and we can represent that 2 ways. We're going to choose the second way because that allows us to cancel out the units of fluid ounces. Now we just multiply the top across the top, which is 946, and then divide by the bottom, which is going to end up with 59.125 milliliters. And milliliters is the only unit left over because the fluid ounces canceled. Part B is very similar. We're asked to find the number of ounces in 100 grams. Well, again, if we look on the picture in the book, we know that 14.5 ounces is equal to 411 grams, and we could represent that 2 ways. Since we're starting with 100 grams, we're going to choose our first ratio so that the grams will cancel, and then we get 100 times 14.5 gives us 1,450 fluid ounces divided by 411, and the grams canceled out, so that gives us 3.527 ounces. I'm sorry, not fluid ounces, ounces. For problem number 35, and let's review that. So essentially when we cancel that, we'll do 35 in a second. When we cancel those items, we are left with the unit that we want. So for problem number 35, what we would like to do is we are given some information. Women have 4.5 million red blood cells, and that's per 1 millimeter cubed. The flow rate at which those blood cells flow is 250 milliliters per minute, and the question the textbook asks us is how many cells per second of blood flow through a woman's circulatory system. And so we're going to write down some conversion factors. 4.5 times 10 to the 6 cells per 1 cubic millimeter, 250 milliliters per 1 minute, and then we're trying to figure out how many cells per second. So based on that information that we were given, we're going to start with 4.5 times 10 to the 6 cells over 1 millimeter cubed. And probably we can convert the millimeter cubed to milliliter, and then we know that there are 250 milliliters per 1 minute, and then we know that in 1 minute there are 60 seconds. So our goal is to get all of our units to cancel, and if we do that, which we did here, we end up with cells per second, which is what the question was asking for. We just have one little piece that we have to fill in the blanks on, and that is the millimeters per milliliters. So remembering that water, and blood is very similar to water, for every cubic centimeter is equal to 1 milliliter of water. But we have to remember that 1 centimeter is 10 millimeters. So cubic centimeters, 1 cubic centimeter is actually equal to 10 times 10 times 10, or 1,000 millimeters cubed. That is our conversion ratio. So now we're going to fill in the blanks, and we're going to say 1,000 millimeters cubed is equal to 1 milliliter. Now we're going to multiply straight across the top and straight across the bottom, find a unit, and then that'll give us our answer to question 35. So we have 4.5 times 10 to the 6. 1,000 is the same as 1.0 times 10 to the third times 250 times 1, all over 1 times 1 times 1 times 6. If we plug that in the calculator, we're going to get about 1.9 times 10 to the 10th, or 1.875 times 10 to the 10th cells per second. Unit conversions are so much fun. I could do this all day long. Thank you. If you have any questions, I don't know, follow me on Twitter at AdamsMath. Yeah, that's it. We're done. Cool.